All right, problem 11 asks us to factor this using the graph. Okay, so what do we know from the graph? Well, we know that this is an odd function. It's not linear, and it has to have at least a degree 3. But let's see if we can factor this. We also know that we have a 0 at x equals 3, which means we have a factor of x minus 3. So that's a good place to start. All right, so that also means if I take this polynomial and divide it by 3, then that should give me a quadratic that I can solve in some other fashion. So I'm going to take 3, and let's see, I have 1, negative 7, 17, negative 15. Bring down the 1. 1 times 3 is 3. Get negative 4, negative 12, 5, 15, and 0. Okay, so that confirms that 3 is a factor. So now I'm going to take what's remaining. This becomes a polynomial x squared minus 4x plus 5 is equal to 0, and see if I can solve that. I know these are not real solutions because it doesn't cross the axis anyway, anyplace else, so I'm going to go straight to the quadratic formula. So a is 1, b is negative 4, c is 5, so x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, which gives me 4 plus or minus the square root of 20. 16 minus 20 is negative 4 over 2. That becomes 4 plus or minus 2i over 2, which becomes 2 plus or minus I. Okay, so that tells me I have a 0 at x equals 2 plus I and x equals 2 minus I, which tells me that the factor is x minus 2 minus I, x minus 2 plus I. So my factored form becomes f of x equals x minus 3, x minus 2 minus I, x minus 2 plus I. Okay, number 12. Use the given 0 to find all the zeros of the function and write it as a product of linear factors. Okay, so what that means is all of my factors have to have an x plus or minus something. All right, so we know we have a 0 at x equals 1 minus I, and the complex conjugate tells me I have x plus I. Since it's a third degree polynomial, I have to find a third 0 or a third factor. Okay, so the factor here becomes x minus 1 plus I, x minus 1 minus I, and I don't know about this one yet. Okay, so I'm going to do this kind of like I did the other one. I'm going to put this in a little box here because this is just information that I need to write my answer. All right. I am method 1. I'm going to use synthetic division. So I'm going to take 1 minus I and divide that in. I'm going to leave myself plenty of room here. 1, negative 10, 18, and negative 16. Okay, so bring down the 1. 1 times 1 minus I gives me 1 minus I. That gives me negative 9 minus I. So now I have to multiply these. I have to multiply 1 minus I times negative 9 minus I. That gives me negative 9 minus I plus 9I plus I squared, which is negative 9 minus I plus 9I minus 1, which gives me negative 10 plus 8I. So that gives me 8 plus 8I. Okay, so this gives me 8 times this here. If I factor that out, this gives me 8 times 1 plus I times 1 minus I gives me 8 times 1 squared minus I squared, which gives me 8 times 1 plus 1, which is 16. And that leaves me with 0. Okay, so now I have to take what is remaining and divide it by 1 minus I. And let's say I have 1, negative 9 minus I, 8 plus 8I. Bring that down. So that gives me 1 minus I. Oh, I'm sorry, 1 plus I, excuse me. So that gives me 1 plus I, which gives me negative 8. And negative 8 times 1 plus I gives me negative 8 minus 8I, which gives me a remainder of 0 and tells me that is also my factor. Okay, then from here, I have my polynomial that's left over is x minus 8, which is my factor and tells me that x equals 8. So now if I want to write my polynomial, this gives me f of x is equal to x minus 8 times x minus 1 plus I times x minus 1 minus I. Now for method 2, I'm going to multiply the complex factors, then use polynomial long division. All right, so my factors are x minus 1 plus I times x minus 1 minus I. Now, as I'm looking at this, I see that I can put parentheses here and parentheses here, which means I have a difference of squares. So this becomes x minus 1 squared minus I squared. So that's x squared minus 2x plus 1 minus negative 1, which is x squared minus 2x plus 2. So I'm going to take x squared minus 2x plus 2 and divide it into my original polynomial, which is x to the third minus 10x to the second plus 18x minus 16. Okay, x to the third divided by x to the second is x. When I multiply that, I get x to the third minus 2x to the second plus 2x. And of course, remembering now I'm subtracting. So that cancels out. Negative 10 plus 2 gives me negative 8x squared. 18 minus 2 gives me a positive 16x, and bring down my negative 16. So 8x squared divided by x squared is negative 8. When I multiply that, that gives me negative 8x squared plus 16x minus 16. When I subtract, I get 0. So I get exactly the same thing. I get f of x equals x minus 8, x minus 1 plus I, x minus 1 minus I. So either way you do it, and it's a personal choice. Okay, so let's look now at 7.5, which is polynomial inequalities and applications. Okay, inequalities, we have to figure out what values of the variable will make it greater than 0, less than 0, or equal to 0. And that's where we start out, is find out where it's equal to 0. Okay, so if I have x minus 1 times x plus 1 squared is greater than 0. Okay, so I'm going to have a number line, and I'm going to have my boundary point on it. So my boundary points are going to be where it equals 0. So I'm going to do this. I don't need to do a very big one because I'm going to do my work over to the side. But I am going to have my, you can call it a sign chart or whatever. Okay, so I'm going to start out by where it equals 0. So x minus 1 times x plus 1 squared, where it equals to 0, is where x equals 1 or x equals negative 1. So that's my 0 here at negative 1 and at 1. Okay, so I'm going to test a point in each of these regions. So I'm going to test x equals negative 2. So if I have negative 2 minus 1 times negative 2 plus 1 squared, that gives me negative 3 times negative 1 squared, which is negative 3 times 1, which is less than 0. So everything in this region is less than 0. In the middle, I'll test x equals 0. So 0 minus 1 times 0 plus 1 squared gives me negative 1 times 1 squared, which is negative 1 times 1, which is less than 0. So everything in this region is less than 0. Then over here, I'll just test x is 2, and you can pick any point you want. All right, so 2 minus 1 times 2 plus 1 squared is 1 times 3 squared. We don't even, this is going to be greater than 0. So everything here is greater than 0. All right, so when it's strictly greater than 0, all I need to know is which region it is greater than 0. So here, my solution becomes everything from 1 to infinity. Now, if I want to do a quick sketch of this, this is a cubic with a positive leading coefficient. That means this end goes down, this end goes up. At x equals negative 1, it bounces. So it comes up here, touches, and turns around and comes back. At 1, it crosses. So you can see that the only place that it is greater than 0 is from here over. Okay, on our next one here, the only thing we really need to look at is, this is the same kind of problem, but our boundary points, we need to find our boundary points. Okay, so so that's going to be where 3x minus 2 squared, 2x plus 1 is equal to 0. So here that means x is 2/3, and here x is negative 1/2. So here I have a 0 at negative 1/2, and here I have one at 2/3. All right, so I'm going to do the same thing. I'm going to pick something smaller than negative 1/2, which is negative 1. So if I plug that in, 3 times negative 1 minus 2 squared, 2 times negative 1 plus 1, that gives me negative 3 minus 2, which is negative 5 squared, times negative 2 plus 1, which is negative 1. That gives me 25 times negative 1, which is less than 0. So everything here is less than 0. Now, at any point on this, if you can figure out, this is always the product is negative. In the middle here, I'm going to check x equals 0. So this gives me 3 times 0 minus 2 squared. 2 times 0 plus 1 gives me negative 2 squared times 1. I can tell from here this is greater than 0. Positive times positive is a positive. So here this is greater than 0. And here I'll choose x equals 1. So 3 times 1 minus 2 squared, 2 times 1 plus 1. This is 1 squared times 3. And again, this is greater than 0. Okay, so less than or equal to 0. So I need to know where it is less than 0 and equal to 0. Okay, so I can do this in the region. This goes from negative infinity to negative 1/2 bracket. And then I also have to include this point. Now there are several ways to write it, but that's how I've always done it. Okay, for C. All right, I've got to factor this puppy. All right, so I'm just going to factor by grouping. So this becomes x squared times x plus 1 minus 1 times x plus 1, which gives me x plus 1 times x squared minus 1, which is x plus 1 times x plus 1 times x minus 1. Or x plus 1 squared times x minus 1. All right, so what does that tell me? I've got boundaries at negative 1 and 1. Okay, so they will be 0 at negative 1 and 1. And of course, I'm looking for where this is greater than 0. All right, so let's start over here and select -2. All right, so -2 plus 1 squared times 2 minus 1 gives me -1 squared oh, that's -2 times -3, which is going to be less than 0. Okay, so all of this is less than 0. In the middle, I will select x equals 0. So that gives me 0 plus 1 squared times 0 minus 1, which is 1 squared times -1, which is also less than 0. And here I'll select x equals 2. So that gives me 2 plus 1 squared times 2 minus 1, which is 3 squared times 1, which is greater than 0. And again, that's all I need to know. So all I want to know here is where it is greater than 0. So the only place where it's greater than 0 is from 1 to infinity. And once again, if you just want to briefly check the graph, we know we have boundaries at -1 and 1. This is a cubic with a positive leading coefficient. At -1, it bounces, turns around and comes back down, and goes back out this way. Okay. And believe me, this is the same as problem 1. Okay, here if you want to do the same thing, and I forgot to do the graph on this one. Here you have boundaries at -1/2 and at 2/3. Once again, this is a cubic with a positive leading coefficient. So you know you start down here and you end up over here. At 2/3, this is where it bounces. At -1/2 is where it crosses. So you can tell that it is less than or equal to 0 from here over, as well as right here. Okay, 3x minus 4 squared, same thing. You just need to find where it's equal to 0. So at x equals 4/3, x equals -5/2 is where it's equal to 0. So you can do your sign chart. And I have -5/2 and I have 4/3. Now I'm going to do this one a little bit backwards. I know this is a cubic with a positive leading coefficient, so I'm going to graph it and then see if everything else lines up. Okay, so at 4/3, thirds is where it bounces, at -5/2 is where it crosses. So it goes up here and then comes across here and then up here. So where is it greater than or equal to 0? Well, it should be everything from -5/2 on over. So let's see if that's what happens. Okay, so -5/2 less, blah, blah. Let's test -3. And again, all I'm trying to do is figure out if it's positive or negative. So if I have 3 times -3 minus 4 squared, 2 times -3 plus 5, that gives me 3 times negative 3 squared is 9 minus 4. So that's always going to be positive. So that's 9 minus 4 is 5 squared times negative 6 plus 5 is negative 1. That's going to be less than 0. Okay, that bears out in the graph. Let's try x equals 0. So let's see. 3 times 0 minus 4 squared, 2 times 0 plus 5 gives us negative 4 squared times 5, which is greater than 0. And finally, we'll test over here. 4/3, let's try x equals 2. So 3 times 2 minus 4 squared, 3 times 2 plus 5 gives us 2 squared times 11, which is greater than 0. And then we have to include the points where it's equal to 0. So it is going to be everything from negative 5 halves to infinity. And that shows right here as well. Okay, switch videos.